Okay, well, this problem number 6 is really very similar to the previous question. Considering this circuit, the switch is in position A for a long time, then it's flipped to position B. Oh, I'm sorry, I didn't have the A and B here, so this is A and this is B. So it's in position A for a long time. That means that the capacitor gets charged, and then it's flipped to position B. So what we have here really is a 6.2 microfarad capacitor and a 50 millihenry inductor, where the 6.2 microfarad capacitor is fully charged by a 34-volt battery. All right, so this is 54 millihenries, and the total charge on this capacitor we can find by the capacitance times the voltage. So Q is equal to CV. This is Q max. That's going to be 6.2 microfarads times my voltage, which is 34 volts. That's 211 microcoulombs. So that's my maximum charge. And I want to know the frequency, and I want to know the current amplitude. So first I want to know the frequency. What's that equal to? Well, my frequency, or excuse me, my omega, is my angular frequency, is equal to 2 pi times the frequency. So frequency is omega over 2 pi. So I want to find out what is my omega. And for an LR circuit, as we've already seen, we already did on the previous one, omega is equal to the square root of 1 over LC. That's the square root of 1 over 54 times 10 to the minus 3 henries, and 6.2 times 10 to the minus 6 farads. All right, so that is it gives me 1728. That's in radians per second. And now I want to take that and I'll convert it into hertz. So I'm going to have 1728 radians per second divided by 2 pi. You can sort of think of this as being in radians, so the radians cancel. If that helps you, you can think about it that way. And this is equal to 275 hertz. So the frequency of this circuit, as it goes back and forth, every second it's going to oscillate 275 times. The energies will oscillate, like we talked about before in the previous problem. Those energies go back and forth, back and forth. This is the rate at which those energies oscillate. So this is the answer to part A. In part B, I want to know what is the current amplitude. Work it the same way as we did before. We say that the magnetic energy, UB, is equal to UE. The magnetic energy is equal to the electric field energy. That's 1/2 Li squared equals 1/2 Q squared over C. Q squared over C. See, the halves cancel. I'm looking for I. So that is the square root of Q squared over LC, which is Q over the square root of LC. And if I do that, I get, let's see, what was Q? I found Q up here, 211 microcoulombs, so that's 211 times 10 to the minus 6 coulombs. The square root of L is 54 times 10 to the minus 3 henries times 6.2 microfarads, so times 10 to the minus 6 farads, and this is equal to my current of 0.36 amps. By the way, you could have done this slightly different way if you wanted. You could have said 1/2 Li squared equals 1/2 CV squared. All right, that would have been the same way, and I'm looking for I square root of CV squared over L, which is V square root of C over L. If you put in those values, you also get 0.36 amps. All right, this is just a different expression for the energy stored by a capacitor. Remember, because you substitute Q equals CV into year 1. That's number 6, and I'll come back for number 7.